Welcome. Good afternoon, everyone. So the last session in this room, and then we will move away for, I think, in the other room for the last session of the conference. So today we will talk about fraud detection with Azure API Management and Microsoft Fabric. So those two services are the star of today. All right, so everybody knows that APIs are the building block of every digital initiative, right? They are everywhere. Everyone loves it. Attackers as well. They love it. Why they love it? Those APIs are so beautiful. They are so attractive because, thanks to APIs, you can control critical data or transaction. You can directly go to personal data, manipulate the business transaction, get all of this big amount of money. So those APIs are a gateway into your business or some portion of your business, for example. Sometimes, too many times, are too poorly secured. Most probably you heard about it. That is extremely important. Also, governance. Okay, you cannot secure what you don't know that exists. So also that is extremely important. And again, all of these modern API or whatever modern is 15 years that are there, they are easily automatable. That enables the attack at scale. All of this automated stuff with all of these dynamic patterns and so on. So let's go a little bit fast. So these are the classical things, but there are way more than this. Account takeover, you just get all of these username and password, and then you scan your APIs, bot attack, data scraping, and sell it out. And then again, as I was saying, manipulating, for example, the business transaction, or get access to portion of data or your company and do whatever you want, if possible, for the attackers. So, but it's not so easy to do fraud detection, especially if you try to do it in near real time or if you have a high volume of data, because you get all of these transactions in, and then it's not easy. You have to manage that load. The fraud detection, the fraud tactics are very dynamic, are very advanced, that every time there is something new, you got hit, and then you learn, and then you adapt, and so on. Most of the time, there is a compromise between the security needs that you have and the user experience that you want to provide to your customer. Easy example, if I'm here in London and I'm coming, I do some transaction with my credit card. I don't want to get blocked every time because it's marked as suspicious. So that's the user experience. I want something smooth, but also I want my CISO want a certain high level of security. And then compliance, privacy, sector regulations is also something that we have to keep in mind. So long story short, I'm Massimo. If you don't know me, I'm an Italian guy living in France, working in Belgium. I love EU since 1993. And if there is someone from UK, hello, Brexit. Okay, okay, sorry, bad jokes. Okay, and today I will talk to you about the case of Contoso Online. Who are those guys? Contoso Online, it's a fictional, not so fictional company. Fictional, okay? So they do provide personalized games powered by APIs. They expose their API to the outside world, to the end user if you want B2C. Therefore, if they have a certain amount of users, the surface area of attack is quite big. They are not in control of the user interface. They provide an API platform. And depending on their customer, they can dynamically provide, let's say, the user experience to them. They do want a secure and performant API platform, and the other key goal is to understand the user behavior. Voila. Those are the two things that we will see today. This is our focus. Let's move on. One step back before going to the user behavior. Let's look where we are starting from. Okay? So, security. There is no such a security model which is perfect. So this wonderful picture is coming from the COVID time. You know, if you have a multiple layer of security, Each layer has its own hole, but at the end of the day, we are quite protected if we layer up all of these kind of things. And over there at the left, so at this side on the backends, we also have different security profiles according to confidentiality, criticality, and so on. So if you look at these backends, you can imagine those backends in different security area with different network profile, with different criticalities, and you might then have a compound API in the middle that then surface those experiences to the outside world. All right. Then let's look those layers in the middle. So our first layer of defense, our Contoso Online, is Azure Front Door. Why this? I was talking about B2C. We are talking about security. That is because Front Door leverage the POP, so the point of presence. In this case, I put in the map the POP in Europe. I think there are around 45 POPs in 20, 25 countries, 30, 35 cities. And over there, the first level of security is applied close to you or close to the players. In this case, we have geolocation blocking, bot protection, custom rules, rate limiting. You can also do some rate limiting, not so fine-grained like in API management, but you can also do a first level of rate limiting over there, close to your user. And also for very, very static API caching experience, you could also have some caching on Front Door, like content acceleration, CDN, and so on. Okay, L1, Front Door. Let's move on. Second layer is Azure API management, and here I understood that most of us, we are in the consultancy business. So classic access control, so authentication over there as soon as possible, rate limiting at a different level. So here I can put rate limiting on the single operation if I have some operations that are more critical than others, for example. Request response sanitization. A few hours ago, they were talking about new improvements on OpenAPI, schema validation, and so on. So all of this kind of validation and sanitization in and out, you can do it over there. And great, we have those single point of entrance, so we can have all of the observability that we want. Third level, if you want, Defender for API, also was mentioned this morning. And here, Defender for API just forward the traffic to this Microsoft Intelligence, and they do threat detection in near real time. And they just find use cases like that one that you see over there that are more technical use cases. We are going to more business use cases in some minutes. And here there are a couple of examples. So if you call an API, for example, from one IP address, generally, but with a parameter that is historically had 700 values, and then out of the blue you call it with 10,000, you get this kind of alerts surfaced by Defender. And then, okay, it depends, is it false positive or not, then it depends on your business. So in the case of Contoso Online, it might not be a problem because, okay, yesterday or historically I have only a few. Today there is a big gaming, so everybody is trying to get to that money, and voila, so you can get this false positive. Good things of Defender for APIs, you can integrate the result with your SOAR, and you can also do, it does some analysis on your API management for misconfiguration. And second thing is also check, no, I did it, yeah. Is also, sorry, identify, you can see here some personal information and some misconfiguration in authentication, and then it can also be integrated with Purview for your data governance. Okay, let's put those three levels all together. That's the first picture: Front Door, API management, security logs to Sentinel or whatever SOAR and CM that you are using. And then we want to, at Contoso Online, close the security loop and use the best tool you want to automate the security feedback back into your defense setup. I've been told you can also use a wonderful product to use logic apps. Okay, but okay. Other people prefer, in this case, XOR or other kind of automation. Doesn't matter. So the important things here, to give a practical example, you can, security analysts can find some suspicious IP, and you can create, update front door. I think it support around 600 different IPs. It's not so much. And then also you have to do a lot of automation to maintain and refresh IPs, because most of the time those IPs are dynamic, and depending also if you're coming through, I mean, if you are behind, or if your users are behind sort of the same IP for whatever reason the gaming solution of your customer is set up. But anyway, same way, throttling on API management is fine-tuned with this kind of setup. Okay, let's move on. Let's keep an eye on the clock. So we had the first platform that scales, that is secured, under control, but now we want, let's say that those security layer, it might be not enough. We want to know more. We want to do something more. We want to understand how our users are using, our players, our customers at the end of the day, they are using the platform, and try to prevent the misuse. So in this case, a valid user on the right, it goes through all of this level, but maybe then here is trying to abusing my business logic, the business logic of the customer. Of course, if you have a state machine, okay, you can only go from 1 to 2. You don't have these behavioral things. But here we have a sort of dynamic kind of platform and user experience. Okay, go to fraud detection. There are some classic techniques. The example of the bank that I told you before, the classic rule-based system. Yeah, we can flag some transaction. We do these things at the back end. As I told you, we have multiple backends. We have over there the business logic. We don't want to do these things in the middle. We want the middle to be fast. Business logic, we implement those things on the back end where we have the business logic. Machine learning model example, the Defender for API, as we just saw. Real-time analytics and behavioral analysis today are other two techniques. Today, the focus is the behavior of our user, understand a typical way of playing versus not so typical way of playing. Okay, let's move to the third step. I don't know if I'm going too fast or not. I might slow down a little bit. Okay, so we are API management, second level. We are in the middle, so we have full visibility. Everything that is dynamic is flying through the gateway. Every business transaction, or if you prefer, request, is flying through that layer, so we have full visibility. Okay, great. And then we can capture those metrics, logs, and traces using the classic log analytics. Or, for example, we can forward these signals to Event Hub. But also, we can enrich those signals in two different ways, mainly at API management. One, by using the user interface, in the sense you can enrich your logs with headers, we can enrich your logs with some configurations, or you can write your own logger and just decide whatever your log will look like, whatever information you want to put in the log. So you have control the click ops or more let's call it pro code kind of things. So let's go back to Contoso. These are the requirements of Contoso. We have a big amount of logs. Okay, so what big means? What big for Contoso means, it might be very small for you, very small. Here I put more than 500 gigabytes per day. I don't know if I did the right math, so it all depends because, again, it's very dynamic, the pattern. They want to keep the data in the store for a certain amount of months, but at the same time, you see, they have different kind of logs, security logs, applicative logs, platform logs. So what are, for me, platform logs, diagnostic logs? Applicative logs is the one of your applications that you host on API management. And then some third-party integration where needed. Here, they might also need, and I will tell you later why, some personal information to track some personal identifiable information. Very bad practice, don't do that. But okay, some people, for some reason, they need that. Okay, so these are the starting point of Contoso Online. Okay, so first question. Yeah, Massimo, why are you making it so complex? Let's go with Azure Monitor. Yes, but. So first things, there are some limitation in using Azure Monitor in terms of performance. And Azure Monitor is not designed for, as I put here, for analytics at scale. You can use log analytics for operational monitoring. Analytics at scale, not really. And coming back on the performance, hey, here our wonderful API management team is saying, if your gateway is under pressure, or if you're using all of this integration with Azure Monitor, you could have a 40 to 50% reduction in throughput. And my first reaction is, who cares? Who cares? I have 1 unit, I just provision 2. I have 4 units, I provision 8. Voila, I got my throughput. Why? Because the cost of 4 units or 8 units is way less than the cost of the storage. So guys from API management, your product is cheap. Don't tell this to them. And compared to storage at runtime. Strategy for personal data handling. So I saw that Contoso Online, they would like to enrich their analysis with some PI. And also over here, there are some advices and best practices from Microsoft. A very simple one, just denormalize your personal information with a sort of lookup table. And then if you want to get forbidden, you just kill that table, and then you are good to go. More complex things, just playing with keys, you encrypt, you trash the key, but then brings more complexity in your infrastructure, and we love to keep it simple here. Okay, so let's get back to what is the setup at Contoso. So from the left, I suppose, or from the right for me, so left yours, we have API management, and over there we are defining multiple loggers. So we are not using, for a cost reason, Azure Monitor. We ingest all of the logs that we need in Event Hub, and then that's the integration part, Event Hub. Then we have the part of Fabric, where we can ingest and transform as needed. For storage, ADX. ADX, Event Fabric, Event Stream, call it as you want. Yesterday I heard, wonderful, it's a good tool for time series. Guess what? It's an extremely good tool also for storing logs and querying logs. He has hot cache, cold cache, is an append-only database. It's scale, you can configure retention and so on. So voila, in this case it delivers. And then you have your analysis things, your analysis part. Just going a little bit into the different steps, and then we go eventually to the demo, but I see that I have time, so I can also take it easy. Okay, all right. Now, let's recap visually what we said. So first part, API management setup. In this case, you have here on the left, okay, whatever it is, on the left, I suppose, a definition of some API loggers. So logs, security logs, PI, and so on, and with an example to just transfer the diagnostic logs. This is an example, nothing special. Or, as we were saying, create your logger. Very important to use manage identities. Then you go, you configure your Event Hub to get the right permission to write. And here there are 3 types of logs. So you have a request, error, and response. And you can see that you can decide how to transmit your logs. Is that JSON? No, Massimo, you are old. It's plain CSV. Okay? It's plain CSV that is sent to the same log analytics. If you want to do this, maybe not. Maybe you could divide three things on three different, sorry, I said log analytics, I mean Event Hub. These are three logs that are sending to the same Event Hub setup. Okay, then you can decide which kind of information to put in your log. So we are not going to the PI because it's not the use case of today. So that was the part of integration, and then we said there is the part of ingestion. Yesterday, there are two types of ingestion with Fabric. One is called direct ingestion, and the other one is called event processing before ingestion. So when it's about a real-time solution, I mean, most of the time you are using the second one because you need to change something. In this case, what we are interested in the first one. Why? Because it's the one that has less latency. I can prepare my log before, and it's also the one that is, guess what? The cheapest one. So here I put the classic old-style ATL to help you and point out the difference. In the direct things, I extract from Event Hub, and I load into the KQL database. In the second case, I extract, I do some transformation using a time window. Can be different time windows, so sliding, not sliding, depending on your business case. But I'm not interested in this case today. But I want to put it there to visualize the difference between the two. Let's see. This solution is not a streaming solution. I put here a wonderful sentence from Clemens. In streaming, you handle data that is coming to you while it's coming to you. Here, I want to just get it and load it in my final database. Now, there is also another way to ingest data that is more pro-code. Like if you love logic apps, you also love the Fabric's ingestion because it's a click ops, and you get your streaming configured. But what if you want to do it more, to do something more, a more pro-code approach? And then in Fabric, you can also use the very known Spark structure streaming, where you can, like if you are standardized somehow on notebooks, you can over there control when to start the streaming, which kind of transformation apply to your streaming, and then how to save it downstream. Here is the example. I just put it for your information, or if you like it, if you have the same kind of problem. So if you want to anonymize some personal data, you can use that Microsoft Presidio is an open source tool that has an analyzer and a processor. I put it over there, yes. You got the input, the analyzer just check if there is some PI in your data. It just, as an output, it shows to you what are the PI, and this response go through the anonymizer that will perform the anonymization. You can extend this tool with other analyzer and anonymizer and get what you want. So Spark structure streaming, it allows also to have a checkpoint to recover from failures and so on. But at the end of the day, it's a classic ATL. So you can extract, you can transform and load. Wonderful things yesterday morning about why everybody are not talking about streaming solutions, real-time solution. We saw an example when there is no ATL, no EL, but it was an ELT. And here I just put a sort of visualization because we are using the same, let's say, direct ingest, but then so we put our data in KQL or ADX if you want. Sorry, maybe I said KQL databases too many times. I mean ADX KQL databases. And over there also we have our data landing into our KQL table. we can use apply update policy to do transformation. So in this case, from classic bronze to silver. Okay, storage. Yeah, ADX is way much cheaper at scale than log analytics and the Azure Monitor stack. Okay, this is like on purpose. There is no scale on purpose. There is it's just to give an idea of the cost that is almost in that case 50% than Azure Monitor. Okay, now very important things also mentioned yesterday. Mirroring. So we have, while we are bringing our data into KQL database, also to give to the Contoso Online people the possibility to analyze their log. That's what they want to do. But then there are also other people called data analysts and data scientists. They want to do something else. And reality check, they do not like KQL. They want something else. They maybe are good with these wonderful Python notebooks. That's why we can, in Fabric, we can mirror a full KQL database or a single table into the one lake. In that case, we can do our ingestion, we did it, our analysis, predict, and so on, by having a single experience without doing any data movement. So let me say, do I need Fabric? I could use Event Hub. I could use direct ingestion into KQL. I could use Databricks, and then to visualize something else. Okay, yes, I could do that. No problem, it will be the same kind of architecture, but one of the multiple advantages of Fabric is this unified experience without data movement on top of one lake. Yesterday, the Fabric team showed some previews. One of the preview is this one. So in the Contoso Online, put together some, let's say, little glue to bring these logs into ADX. If you just enjoy this, join this preview, and you might do like me, put a checkbox API management, so then we get this log into Fabrics without doing anything, so we can relax a little bit. Okay, now, good, I'm in time. So let's go to the analysis thing. So we had our data into our databases. We potentially, we have it at scale, at cost is good. And now we go into the analysis part. So there is this, let's say, it's Linda or Maria, whatever you prefer. She wants to visualize how the players interact with the different API operation. Okay, let's call it Linda. I got it. So that's point number one. So she wants, thanks to the mirroring, she can just do her analysis. Let me press. And then we have John, okay? And Johnny wants to categorize the different players, understand the player behavior, and go a little bit more into the black magic. Okay, let's make the data work. Let's go to demo time. But first, one thing. So what I'm going to show right now, there is nothing that belongs to, I mean, it's all belonging to Contoso Online. API names, operation, everything has been randomly generated. There is no real data, no production data, no PI information. On purpose, I'm using the IP address as user identification to make it extremely generic. But there is only one thing, the sequence of the operations of API operation, to make it sense, it comes from a real use case or 90% of it. I thought it was a good number to put, so what it means. It means everything and nothing, but okay, that 90%. Let's move to the tool. Okay, 25 minutes. Oh, I can slow down. Okay, one of the things that I love, this is our Fabric, the Fabric of Contoso Online. There is this wonderful visualization that helps us to see the data pipelines, how the data are, not the data pipelines, how the data are flowing in our system. You could use this visualization. You could organize with folder. I find it anyway nice. So let's explain me, because Massimo, a lot of words, but you didn't explain anything so far about the real use case. You might say, okay, let me explain better. That's what I want to achieve. We have our raw data that is in our KQL database. We want to clean up the data and go to the silver layer, and then we want to transform the data for our intent, for our analysis goals into the gold layer. That's called the classic medallion architecture. Everybody, medallion architecture. 20 years ago, we were doing the same things. We were calling multi-staging data pipeline, but today everyone is excited to say medallion, so I'm also saying medallion. Okay. Now, what we want to do here, let's look, for example, the first one. I'm calling an API, one node. One node is an operation. Then I call another operation, and I want to define the interaction from one operation to the next. So I call login, then I call get profile, then I call something else. So every node is an operation, and the connection between one node and the other is the edges. So nodes and edges. You can also have graphs that have directions that says I go from here to there. And then you can also have the probability. So I want to know how much I go from one operation to the other one with that probability. This is the goal, one of the goals of today. So this is the context. Let me go to the second step that I told you we need to prepare some data. But first, I want to show to you something. We said that beautiful mirroring, that is disabled by default, but you can go on a single, if it's clear here, on a single table, and here enable this, with this, the mirroring on one lake. Now, to make everything simple, I start from lake house. Let's do like this. I start from a flat file. I'm not here to create, to simplify the demo. I'm ingesting this test file with Azure Monitor and logs information, and I put those things into our KQL. So what do we have in this file? Classic things, right? So we do have our, where it is, operation name, some API somewhere, and then we have here the API name, and somewhere we would have status code, etc., etc. So this is the starting point. Very simple, very common to everyone. And then we want to clean it up. So let's clean it up this way. Yeah, let me first, I should have warm up the things, but anyway, let's see if it's running somehow. So first things I'm doing here, I'm just reading my data. I'm just importing a sample file. I create my Spark session, and I just show what is inside the data. So this is what I showed to you in the flat file. I'm using Spark version. I'm using, that's Fabric. That's our starting point, and I might, out of all of this file, select only the fields that I need. I don't need to bring with me the complexity of that flat file. I just only want the information that I need to build the analysis that I'm interested. So I just run this, and I got something like this. So from the file, in one simple command, I go from a structured file to a flat data frame. Okay, that's good, and I have timestamp. This, as I was telling you before, this is just, look at this as user ID, or if you want user ID plus session ID plus game ID, it can go multiple dimensions, but I make it flat to make it simple. Then I might just clean up my dataset to remove some noise, to rename some operation, to filter some operation out. So far, so good. So that's the kind of the things I do. And then I update my destination table. So I'm using delta table, which is based on Parquet plus the increment, let's call it transaction log, that represent all the changes that I do on that table. And then the final result, as before, a simple table with few, again, operation name, API name, result code, and timestamp, user ID. Those are what I need, nothing more, nothing less. So this is my silver layer, okay? So from a raw file to some data frame in my delta table. Then I need to move to, I want to create a graph, and I need to move to gold. One of the things I didn't show to you is is in this. Let me run this. So, of course, I did the transformation on a simple file. Here, I'm not loading the data live, but what we have, or let me go back here. You remember, so here I'm running the data of 1 hour. So let's say that I might have 6 gigabytes per hour, something like this of data that I already loaded into this transaction silver D3. Okay, and now we will see how to go from transaction silver D3 to the nodes and edges that is my gold layer. So let me go back here. This is the way we go to gold. Here to remember, I put this big arrow to follow up. Let me run again. Here we are, even if the IPs are randomly generated, to even make it more clear, I update 5 IPs by calling them London, Tokyo, Dubai, Cairo, and so on. And here I just want to understand a little bit which data I am looking at. So with min and max timestamp, some data about transactions. Okay, so we are going back to the future. So we have 1 hour in February 19, 2026, my birthday. Yeah. Now you know. Oh, I said there were no personal information. I'm sorry. That's a personal. Okay, it's 1 hour, so from 4 o'clock to 5 o'clock. So we do have 2 million transactions in this data set. So 40K transaction per minute, 700 transactions per second. That's in the data set that we are looking. We have session, 40K session. And if you look in London, sorry, the user code London, not the country, just a little is doing just only 63 calls, Tokyo 81, and so on. And then this is what I showed to you before. Now, how can I move this into gold? That's the, I've been told, is the boring part. Let's see. So, first of all, I need to partition my data, my table per XFF, so per user, and putting an order by timestamp. Why this? Because the order of the operation is the way I play. Then, second step, here I just collapse if is optional. That's just to make it simple, the result. If I go from one operation to the same operation, I just collapse it to the single one. So if I do like this on the gaming, so I refresh 3,000 times the same page, I make it simple, I collapse, otherwise I will have just, how do you say, on the same node, a sort of self-referencing things. You can have it, no problem, but just like to keep it simple. That is optional. Second thing, using the lead operation, I can calculate if I'm on the operation 1, what is the next operation? And then it's done using the over the window specified just on the previous command. I filter out the rows that have the next operation that is not null. Why this? Let me remember. Okay, it's just because I want to make sure that I will not have the last line in my table that is that represents the last operation, and we say, okay, I'm on the operation, let's say, log off. What is the next operation? Null. So I just remove this line from my dataset because anyway, the last operation, the log off, is on the previous record. But okay, it's just a detail. Then the one that are more interesting, I need to calculate how many times I go from transaction A and transaction B. I have a picture for this because, and that is just a simple group by, okay? And then a count on my group by. What I'm doing this, that's the image. I want to know if I go from get profile to get account, I just want to do the count. How many times? That's what this picture represents, I mean, is a visuals of this line here. Okay, so group by, XFF, operation and operation name, plus a count. Once I have this, I take these transition counts, and I also do an additional group by because I want to calculate only the outbound transition, which is this picture. So I want to know only, for example, for get profile, I want to sum all the occurrences where I go to something else in order to get to that 6. So 2 plus 3 plus 1. That's what it does. So if I have the total outbound, I can divide my 2 by 6, my 3 by 6, my 1 by 6, and I have the transition percentages. That's the things. And that's what I'm doing here. So I just join the two data frame, and I just divide 2, 3, and 1 by 6. So I have my percentage, so I'm happy. And now I select only the operations, only the columns that I'm interested. My user, starting from operation, going to operation, probabilities. Simple as it is. Okay, and I save it into a table because I want to persist these things in my gold layer. Now, let's see what is the result. It is in the next notebook to make it, say, Massimo, a lot of wording to go to the point. Come on, yeah. Okay, next one. This is the last point. So here, so we move from our raw data all the way to the bronze, all the way, and then we arrive to the gold layer, and now we can do this beautiful analysis here. Here you go. Let's see. Okay. Is it running? And here I just want to show to you 20 lines of that transformation that I tried to explain. I hope that it was more or less clear, but just like creating what we are going to see in 1 second, 15 seconds or 20, 21, in some seconds. Okay, it's coming. Okay, so that's the result, an example of the result. Again, so I go from get tools to get money, 21% of the time. From get money, I go get chances, but also from get money, later, I will go get bag of money. So, and this I go 44% of times, and so on. This is classic nodes, edges. This is the edges, and these are a node, and this is the probability. Okay, let's plot it. Python has a lot of nice way to plot things, and here I use a very, cache does not, okay, it's coming something. Okay, something, but okay, we don't read the errors, and we just got some basic sample. We put on a round visualization, we put our operation on the edges, and I put I put the operations, the nodes on the circle, and we have this linking. Okay, so far so good. Here, the example, I go 100% of the time from how there. Okay, I go to, get money. That's what everyone wants. But okay, this is not so nice maybe, so let's do something else. And then you can, Linda, start playing, start finding the visualization that is best for her. Maybe she wants to understand where the game is playing to help her focus. And then she starts improving the visualization with some black magic Python. And for example, let me here and just create some visualization like the following, where I put in blue where you go from left to right. I put in green when you go to from right to left, or vice versa. I put all of the size of the transition bigger depending on the probability and so on. And then you can do all of the games that you want. You can filter to do whatever analysis that you prefer. Till the final step where we want to put, or Linda wants to put 2 sessions side by side to try to understand how the user London behave compared to the user, I don't recall the user 2 who is there, but it will come if this, if my friend Spark, okay. So, and here we can plot, in this case, London versus Tokyo. And we can try to do some analysis. One of the things that comes to my eyes is this subgraph. It always go from left to right, and then go up from how there to money. And the same behavior is present on 2 graphs. Is this a valid behavior? Not. That is up for the business domain at Contoso Online to understand. But we can compare whether a subgraph, for example, is present into a graph to categorize our users, to maybe define, okay, this is the behavior that is valid for the game X, for the session, whatever it is. And in that way, we can take this graph, nodes and edges at scale, calculate, persist, and do our analysis. For example, if, and this, okay, Massimo, easy, you just put 2 things that are similar, okay. Yeah, I agree with you. Let's try another one. Let's see what happened. I changed to another IP, another user here. I just run again my visualization that hopefully is faster. And then don't ask me why they are completely different. So I'm comparing 2 graphs, 2 user experience, 2 games or 2 whatever it is that are not the same. Maybe are both valid. I have no clue. It's up to Linda and all the domain expert to find it out. So this is to close, this is the experience of Linda. Now, how we can get out from the data analyst mode and go, data engineering mode and go a little bit into the data analyst mode. That's the next step. Okay, so let me go back to the slides. Oh, am I? Okay. Okay, is back. Okay, next step. We have all of our data into this beautiful one lake, and we have our data analysts that engineering that are happy. What is the next step at Contoso is to identify personas. So in ML, you have 2 types of machine learning or techniques, unsupervised learning and supervised learning. So in this case, the first step was running unsupervised learning. What does it mean? We want to put together cluster of users to identify personas. And this grouping is done by patterns. So if you have, suppose, you are a user, you have some features. So you have the country, how many money you deposit, and how much time you go from login to the first, let's say, bet. That could be 3 features. So you plot these 3 features into a 3D space, and then you have your point. So that's what does the unsupervised learning do. So they put all of these points into this 3D, for example, space, and then the points that are closer, those are clustered. The ones that are outside the cluster, that are outliers. So this is a real example on only 2 features, so 2D. and you can see some groups of clusters and some outliers. That is the first step, okay? But this sometimes, this kind of things needs to be enriched because it's really quite too much quantitative data. We can enrich with some more qualitative, and it might be like, how do you say in English? Interviews that Contoso Online does with their users or a set of their users. So they can really create a personas that represent their players. So they can enrich this with that data. They can also enrich this with what was coming from the personal PII flow, okay? So to make sure we know who our player are, and then more data we have, better insights we have, better decision we can have. Okay, then another more complex things is going to take that experience of Linda or Maria, let's say stick to Linda, and bring it into the world of John, okay? And here there are some techniques of anomaly, graph anomaly detection. There are also some isomorphic things, but I don't go into that. But the classic one is like at node level. In this case, we don't care at all about node level because a node, in our case, in Contoso Online, is an operation. I cannot have unknown nodes because the operations are defined in API management. If you call an operation that doesn't exist, is a 404 or whatever that I will not have in the log, or I can filter from the log, etc., etc. So I don't care the first one. The edge level, if there is a clear transition that is not possible, that is very easy to catch. The one more complex is the subgraph, because if you want to run this graph anomaly at scale, you need to define what are the subgraphs that are outliers. And that's the point here, where you have the semi-supervised graph anomaly detection. So one technique is to, because it's difficult to know what are those outliers subgraph, you might on purpose create fake subgraph. So you create your, you provide negative, you build up negative path to train the model, even if it sounds weird, but that's one of the techniques. You train the model by faking the attacker, let's say. And then some other things that are more in the black magic, but the wonderful data scientists, they break their mind into this. Okay. Ooh. For the first time in time, in my life, I'm on time. So I'm very happy. Let's wrap it up. So what did we saw today? Did we see today? One, you want visibility. API management give to us great visibility, and we can configure it in a multiple times up. Second things, we have a huge amount of data. Think about ADX, standalone, Fabric, doesn't matter. But at scale, you save money. If you have plenty of it, no problem. But maybe your customer would like this. Second things, Fabric give us this unified experience from data engineering, data analysts, the one that want to visualize, and that allow us to have our data analysts doing their graph comparison or graph understanding and categorization, but also going all the way in machine learning, training the model, building the model, and having the inference endpoint for that kind of models. That brings me to the end of these sessions. We love APIs. APIs are your front door. So let's make sure that we know who's knocking at that door. It took me a lot of time. I had a red dress, first slide, to find a postman on a red dress to just get the link between APIs are attractive to hackers and knowing who is knocking on the front door. That's it.